So today I'm just give you some how we're going to work this workshop. I'm going to also talk a little bit because some of you might be interested if you're graduate students or students doing research on social media, but the overall workflow for the analysis, and this is one approach for the analysis of social media data. So we're going to talk about network analysis and text mining in briefly, but the workshop is about text analysis and text mining. On the hands-on part, we're going to look at Twitter data, textual data, only the content of tweets, because you can do many other type of analysis. But we focus on the tweets. We will do some preparing the data. I'm going to using a framework called tidy text. This become more popular, and we get some descriptive analysis information about tweets, about the number of hashtags, most frequent hashtags, their frequencies. We talk about the networks among like hashtags and mentions of the people, and then we try to do a little bit of topic modeling. And we'll explain a little bit what's topic modeling, how we can learn. And at the end, if you have time, I will show you that how you can build all of this into an app. We had some Shiny app and it doesn't mean that the app is Shiny. Shiny is the framework for building app. So the housekeeping that everyone was talking about, as Mark said, we're going to use this rstudio.cloud platform, which gives you a full RStudio IDE in your web browser. It's actually because when you open RStudio IDE on your computer, which is actually a web browser running, a WebKit browser running inside the frame. So this is exactly the same thing that you get on if you install it on your computer. It's very convenient, and one of the things that, thanks to Mark, he suggested we do that because there are different packages we use. So I installed all the packages and everything and all the code in an R Markdown notebook that you can have. So what you need, you just need to go to RStudio Cloud, and they have a sign up button on up right. When you click, email, just a password, and you are in. And when you are in, you please go to this URL, rstudio.cloud/project597419. That is where the code exists. The good thing about it is that I can have my code, and you see the same code. But when you start, you can edit it, you can tweak it, but it does not change my code. So it creates a copy version for you, and you can save your customized version for yourself. You can also download that file or that R Markdown document, either copy paste it or just download it and bring it on your laptop and do further work with it. We will do that to do. When you go to this site, you will see something called like analyzing Twitter with R. Can everyone see that?
There's nothing to see here, sorry.
Oh, actually, you have to remove the S and projects and the URL. That's what I did.
You need to say projects?
It's project. So in your URL, yeah.
Oh, okay, I see.
Is it
project, not projects?
Yeah.
Got it.
No, he has it correctly.
Okay.
You have it correctly. I think here when you're
okay.
around and
Yeah, so what you should be able to see, most likely it's if you're seeing here or if you're in the project, you should see something like this. And if something like this. You can close this. If you pin it, it's going to be here, but because I want to use most of the space, so you're going to see it. And if you want to focus on the first window, the shortcut is Shift-Control-1.
Actually, it doesn't even default to opening the script. So you have to show them where that script is and how to open it.
Is it here?
No, it just shows the console. It doesn't
Okay.
have the notebook open.
Okay. We're gonna get there. So in the folder down here, in the files, if you go to the file, you should be in the main folder, which is the project folder. Can you see this?
Yes.
So if you go to the notebooks, there is a text _analysis.rmd, the one here. If you click on it, it will open in this pane for you the page. So I will give you a little bit. So that's if everyone is there. So we're going to switch back to the presentation. We're going to get back and we start talking. Because you don't need to run the first cell if you want to start. Because I already installed all the packages. I included them because if you copy this notebook on your personal laptop and wants to run it, it helps you to install all the packages you don't already have. Okay. Okay. So now we are good. So you can save it for yourself. You can download it and do whatever. So just quickly talk about the workflow for social media data analysis, as I mentioned in the earlier presentation if you attended. So we can look at social media in different ways. So I want to use this concept from Moretti, who's talked about distance reading and close reading. So the idea is that the scale of the data, it's so large, and I think the case that he used that if you want to read all the novels written in 19th century, and you read a book very fast every day, it takes you 100 years to read all the bodies of literature existed. So there is no way for any single human being can read all of them. So do the close reading and analysis. So we need a way of distant reading. You can read things in the whole corpus and identify patterns, identify the things that are interesting, and then conduct the close reading. So we use the same metaphor and the same approach for distance reading for social media. The scale of data being produced for social media is so massive that we cannot usually do more enriched qualitative ways of reading of a lot of text. So we need to use some of these distant reading methods to identify the most interesting or important things that we care about, and then try to dive in and do the close reading in the cases we need. So it helps, this distant reading helps to get an overall understanding of the structure of communication, for example, in social media, understanding the overall structure of content as well, how the content is distributed, what is it about, most of the conversation, what it is about, who are the most influential. So this morning I talked about the most influential users in information dissemination networks, and then the content they share. And then this distant reading is helping us to do close reading effectively. For example, we identify very interesting communities, and then we go read the most influential or elite content that they generated. That's what I said that my student Hussein did for the analysis of narratives. He identified what are the narratives in different political communities the elite are talking about. How do they frame the situation, political situation? So there are many ways that you can apply computational methods. The two approaches that I'm talking about is social network analysis, or SNA, and text mining today. So network analysis approach, so try to look at the social structure, social phenomena as two things, as nodes and links. So node can be any entity, it can be universities, and collaboration between universities can be linked between the faculty. It can be corporations, if they do joint ventures, that can be linked between them. It can be human beings if they send letters to each other. It can be social media users. For example, in Twitter, you can have social media users. If I retweet you, there will be a link between us. Sometimes links have a direction, sometimes they don't have. Friendship is a bidirectional, but if I follow you, this is unidirectional. So I said that you can map something into a network. For example, this morning I talk about information dissemination network, and we look at retweet network. Retweet network is a way that information passes through users and propagate in a network. When we look at the information, when we want to see who is the most important person in dissemination of information, we need to look at that network and identify the biggest centralities. So that's the case of retweet network. What we can learn from the retweet network, it was the centralities. Who are the most effective nodes to pass information to other people? This is when we look at betweenness centrality or closeness centrality. Who are the most influential? We look at things, metrics such as a page rank. So this is an approach we look at. Today I'm not going to talk about social network analysis, just want to give you. And then we can also look at the community. So there are algorithms that can tell us which are the most connected, closely connected to each other than the rest of the network. So whether that means they are a community, and we can identify those communities. And this morning I showed that there were like different political groups emerge as different communities, and then we identify the most important influential users in those networks. In that document that we will share, I share the same text written in that R Markdown notebook, and you can read it if you want. I also provided some links to R packages and Python packages that you can do social network analysis. I also mentioned, because some of you asked me about what tool we might be able to use for collecting data, there's a tool called DMITCAT that I provided the link in the notebook. It's a digital method initiative at Amsterdam. They developed this digital toolkits for Twitter archiving and collecting. It was very robust. It's very easy to run. We run it in the cloud. We use it on Amazon Web Services and our own cloud when I was doing that research. And it's capable of collecting millions of tweets. So we looked at the case in Turkey. We collected 40 million tweets over a period of a couple of weeks with that platform. So if you want, you can also check that link. So a little bit about text mining approach. I think I already alluded about that. So with text mining, we can get some basic descriptions. And this morning I tried to say that even some of the basic statistics, like the frequency of tweets, can be revealing some patterns. For example, network disruptions, whether it happened during an election. So you can look at distribution of tweets over time, the most frequent terms, hashtags, mentions, the paper that one of the faculty of journalism, I'm sorry, I keep forgetting his last name. Blevins. Dr. Blevins published, they looked at the hashtags and the structure of the network between the co-hashtags and hashtags over time after the Ferguson shooting. And it was very interesting while it was looking at very simple things like hashtag, it could develop a nice way of how the narratives around this Black Lives Matter and the shootings developed and changed over time. And it was very interesting study. So it was recently published in New Media and Society, so you can read it if you're interested. The other things that we can learn, it's like topics, if you're interested to see that, what were the most important topics of a conversation. It can be done for product reviews if you're selling sunglasses and you want to see what people likes or hates about your sunglasses, or what were the topics associated. Actually, some of the people I knew who left academia was doing that type of work. I'm not. But so you can look at the topics and which topics are prevalent over time. We're going to do a little bit of that today with topic modeling, and then what different topics are being discussed in different communities. So if you identify the communities in the network, then you can go collect their tweets, and then you can run topic modeling on the corpus of the tweets from the community and see what topics, for example, in that specific political affiliation, people with the political affiliation to a party are talking about, and how you contrast it with another party. So sentiment analysis is another thing that text mining you can do. We are not doing that, but I put it here because we used it in the presentation this morning. There are two approaches to sentiment analysis. So one is a lexicon-based, so they pretty much look at the frequency of positive and negative terms in an utterance or in a sentence, and they sum up that to get whether it was a positive expression or a negative expression. So there's studies shows that lexicon-based have some problems, especially when they're dealing with sarcasm or issues that people might use completely opposite terms with the context to providing the other meaning. There are supervised learning, machine learning methods that you use a body of annotated documents, so human coders can go and say that there was a positive review. A lot of companies, they're doing it for like IMDb or Amazon are doing this type of things, where the people wrote a positive review for a movie. If you go to IMDb, they have a meta score. That meta score machine generated. They look at all reviewers' feedback in different newspapers and other outlets published, and they interpret the weight of positive or negative. And actually, that usually, I use it personally. I think it works better than the people's user ratings. Or Amazon use it to find out whether it was a positive or negative review. So they are mostly machine learning based. So they have a group of human beings. They read these things. A lot of people use Amazon Mechanical Turk. This is a platform that you can assign a lot of jobs. Humans pay like pennies or cents. They say, oh, this was positive, that was negative. They use it as a training set. We train algorithm to learn the patterns, and then we applied it to a body of text. So I mentioned this morning a package called Fast Text, which is also available through command line or R and Python. It is very, very convenient and easy to test, and it uses very good methods for text representation. We used it ourselves for analyzing the sentiment in 2017 election. There are more advanced ways to do. I tried to experiment that. I remember that was one of the questions that, and there was a report that Berkman Klein put in 2017 after 2016 election, they looked at political polarization. So one of the things that we can do is that I can use sentiment analysis to look at someone's tweet and look at the specific name entities that tweets. For example, so that we are talking about the president and the rival running in election. And you can find the sentiments. If a user has an overall negative sentiments towards a candidate, we can say that this has the other political affiliation. Especially in the US, it's very simple because the two parties, they're not both parties. If they have a very positive about one candidate, you can feel that probably they have more loyalty to that party. So you can use that, then mark the political orientation of users. You can also look at what content those users shared. So you can see which links being shared with people who have, let's say, Republican affiliation. And then you can see that the distribution of attention to media sources based on political affiliation. Things are start getting very exciting when you start putting them on top of each other. So you use sentiment analysis to find people's political affiliation, then you can start looking at the media distribution, what content they used and when they shared, and you can then create a map of distribution of, or how you can call it, polarization of media use. So that was a quick. So that was actually what I was mixing the two methods. So you look at social network analysis to identify communities, then start applying topic modeling for the tweets they shared. They identify the distribution sentiments toward a specific content shared within a network, and the things can just multiply from here. So for today, so we are going to spend most of our time today talking about doing the hands-on. So we will use a framework called tidy text. There is a paradigm in our community, and it's really polarizing. Some people love it and some people hate it. It's called tidyverse. I really love it. I am a fond follower of tidyverse because I think it makes data science jobs very easier. There is this idea that Hadley Wacom wrote a paper about tidy principles of data manipulation and data management and working with data, which was very smart in my opinion. And then because he is a man of his word, he started building these tools that follow those principles. And they make life much, much easier in our world. So he built this dplyr, which is the data plier to mending data sets and working with data sets, and then he started building other tools and packages. And it makes working with the data sets easy. So now they have a set of a website. If you go to tidyverse.org, there are many packages now come out supporting those principles. And the good thing is that they give you a coherent way of dealing with things and expecting how things should be done, so making the learning curve easier. So it might be a little bit, I think if you're new to R, definitely it's easy to learn it, but if you are one of the old users of R, using R in 2001, it might take some time to start using it, but it's worth it. So Julia Silvey and David Robinson, they published a book. I have the link in the notebook. It's free open source, you can access it, called Text Mining through this tidy text, and they developed this package, try to apply those same principles of tidyverse and tidy principles to text mining. Because formerly what we used to do, we created these objects of corpuses of the text and very hard to work set of objects in R. A lot of packages still working with that, but I try to follow tidy text because I think it has a easier learning curve. We can learn it quickly and start getting a lot of things already built into it. For example, they built a tokenizer that break text into tokens for Twitter. So you can just clean a lot of things for you. You don't need to go and clean up a lot of things. This is just and as I mentioned, we're going to prepare our data, do some descriptive counts and frequencies, look at some co-occurrence of terms, and then just spend some time to do topic modeling. We are using structural topic models, which is a dialect of topic models. And we also talk about how we can find the best number of topic models. Topic modeling, in my opinion, is art and science, because you have to really play with it a lot. Sometimes you get a lot of nonsense out of it. Sometimes you get very good things. Sometimes you don't get anything out of it, honestly. But it's a very powerful tool. Okay, so let's stop talking and let's start working. If you are all here and you open that text analysis RMD file, I just go here and maximize my page. So this section, let me just explain a little bit. If you're not familiar with R Markdown, I really love R Markdown. It is a very simple way of writing research and code, especially when you do we talk about reproducibility, because what I've done here, I want you be able to reproduce it. That's an important pillar of science. Now I'm working in industry, I see it much more important, because when I do an analysis, we have a model review or a code review, so another colleague start to do the same thing and go through to figure out whether I mix something, and they should be able to get exactly the same results, and if I have made some mistakes. So it is very good because I can write plain text, I can write code, I can have the code and results within that, and it also generates nice outputs in PDF or HTML. Sometimes I can just send the HTML code to the people. I'm not sure whether, so let me show you. If you go there, you can also see there is a HTML file. If I click on it and open it in the browser, so that code is being rendered to this like readable, nice. You can also get it a PDF. The links that I mentioned are available there. So when I'm writing I really like it, because when you are writing a research project or a paper, you make a lot of assumptions. And when we are in the middle of it, you think that I will definitely remember all of this. Fast forward 3 months, you say that, why did I pick that 5? Why should I be good? I know it was I had a very good reason. And it reminded me of Hegel when a student asked, what did you mean here in the book? He said, when I was writing it, I and God, we both know what it means, but I think only God knows what it means now. That happens to me many times. When I'm writing in this format, I just make my assumptions here. So I pick 5 because, we had this analysis and we heard from that guy 5 is the best things, that's the citation. And we go down. And now actually I've done some analysis last year in my job to find out what factors contribute to someone get a job faster. And then almost 11 months later, someone said, can you just tell me what was that? And I just opened up, I thanked my former self, said, thank you, Emad, thank you for writing all the notes in the document, because I can just copy paste. Yeah, that's it. So I wrote a little bit of text for you here, but I just want to show you that you can use R Markdown, and you can also get the PDF version. People write papers in it, and if you go down there, you see that I have cited things with, so it is very convenient way to do that. And so this, again, this section is all the packages. If you don't have them on your computer, you can run it on your personal computer and install those packages. We are using R version 3.6. And you don't need to run this cell. So we go to the next cell. So these are the packages I'm going to use in this analysis. So I think you have to run that. So it's load all the packages. So tidyverse is the framework. Lubridate is the package dealing with the date and time data. And tidy text package, as I mentioned. Quanteda is another framework for doing text mining. It's very popular for people. I just want to give you some exposure to that. STM is the structural topic model, and FAIR, which is based, that's again, Hadley-Wickham has a package called PAIR for doing functional programming, and then it's based on future for using multiple cores on your computer, because R by definition is a single core. So it uses one of the cores of your computer. If you want to do things in parallel, multiple cores, because all of the laptops now, they have multiple cores, you can do things such as pair. I'm going to show you how you're going to train multiple topic models with FIR. So that's the text, that pretty much what I told you about. I put some links. If you're interested, you can get that. But let's go to the first cell called data cleaning. So I have a data set. So I have my way of doing R, and I think that's if you spend some time with R, you figure out there's a concept in R called projects. A project maintains everything you have for a project within a folder. So you can have your data sets, your code, and it's always very smart. It knows when you open a project, it knows where it is, the working directory for that project. And if you have a structure that you keep using, for example, all my notebooks are in a directory. All my data is in one directory. It tells you that. So okay, so we were in project. Now I am in notebooks. I use a simple structure. In my work, it's a little bit different, but for here, it's like this is the project. This is a project.r project that store all of your history. If you close your tab, you close RStudio and go home, and tomorrow come and open it, it will open your last tabs which were open, the state all the files they're capturing, and then you can keep your models in a folder, you can keep your data in a folder. So I have for example, a data folder for raw data, and I have a data folder for tidy data, the reason I mentioned all this because I want to tell you another thing about. So we're going to read the data. So when you are reading the data, one of the issues is that if you see some people said that /mydoc /emad /0 and then there is a file and then you want to run it, you can't run it because that file is somewhere else. So there's a package called here. Here always, if you all open it in the project directory, you say that here, I'm in this folder, and in this folder go to the data, go to the raw, and look at this tweets.csv. So it's a comma-separated file of the tweets that we got for the tweets. The data set that we're going to look today, because this event was at the library, we thought that it would be fun about libraries. It is a tweets data set for ALA campaign. American Library Association had a campaign, Library Transform, and they tried to bring the president of ALA at times tried to start this campaign to use social media, library more engaged. So we were interested to look at what's users' interactions, who is talking about Twitter on ALA, about libraries. So that's the data set. It's over 2 years from towards the end of 2015 to January 2018. So we look at it over a couple of years and say that it has about 70,000 tweets in it. So it's stored in that folder. If you collect the data, you can go and see the CSV file format. But we're going to read it with a read CSV, which is a function from the family of tidyverse that you can see. So if we call this a code chunk. If you want to run a code chunk, you can run it here, or you have a run up there. But if you select a line and you want to do it one by one, if you get Control and Enter, it just runs that line. So I just ran that line. I read that CSV file, and now I have a CSV file here for tweets. It has almost 68,000 tweets. And if I click it here, you will see that it has a couple of columns. It has ID string, which is the ID of the tweet ID, which is unique. And because I don't specify it in reading, it's assumed that it is a scientific number. So show it this way. We'll fix that. It's a date created, but this is a text object. There's a user who is tweeted. This is the full text, and then the language that the tweet was, and that's the Twitter language classifier. Yeah.
How do you run a single line? Control?
If you stay on that line, Control Enter.
Stay on the line and Control Enter. I see.
Okay. So we had that data. We read that. So what we want to do here now is we have to do some cleaning and preparation. So I mentioned that the ID string that you saw, it was in a scientific number, and sometimes R might do weird things. You might get a mean of the IDs, but you can't get a mean of the IDs. So IDs are kind of can be text. So what I'm doing, I'm turning it to characters to understand that I'm not going to make that mistake. I'm also going to change. I will replace the zeros that you have seen in the date, and then I have to parse the date and convert it to a format it was, because it's a text now, so that R does not understand it as a date to be ordered. So going back to show you, So the date is like 3-letter abbreviation of the day, 3-letter abbreviation of month, 2-letter digit, hour, minute, second, year. So I get rid of these zeros, and this is a universal time format. So what you will see here is that I changed that, I mutated that, created that, to replace those zeros with nothing, and then convert the time to the proper format. And then I started renaming things because I said that I prefer to have ID instead of ID string, and text instead of full text, because in Daisy I don't want to talk too much. And for the purpose of this presentation, I filter and I only keep English tweets. There were non-English tweets as well.
What does the function mutate do?
So mutate is part of that deployer package that I said, that tidyverse. So mutate is mutate a column for you. So for example, this column, it's changed the nature of that column. It lets you apply some transformation to that column. So we have the column created at. It tells that, hey, replace the strings for the column created at, identify this, and replace it with nothing. It means like you remove it. I could also use a string remove and to do that. So here I said that mutate this column by transforming that string to a time date. So when I apply that, and here I rename, and then I filter everywhere language is equal to English. So again, if I press Control Enter, if it does it, if I now open the tweets, you will see there. Is it done? Oh, this is web-based. I have to do it again. So now there's 63,000. There are 4,400 non-English tweets. Now you see the IDs are fully written. The name is ID. The time date has been changed. And then the rest. And everything is in English. So, so we've done that. So the next step is that we want to cleaning our text. A lot of junk comes with a tweet. When I say junk, because in this presentation I'm not interested in URLs or links people shared, and I'm interested in the content of, so I want to remove those things from the text. So one of the ways that we can give it a set of patterns and tell them to remove that from the text. But tidy text has a good things. It said that it can token tweets. They built something in there, it's tokenizer, that says that, hey, when it is tweet, remove URLs and punctuation, lowercase, everything. So formerly, when we used to do it with other packages, we had to set everything to lowercase, then remove extra space, remove HTTP, something like that. Remove everything and start with HTTPS plus any words, any ampersand, greater than, smaller than, all these things. Now, thanks to tidy text, we just say that, tokenize this tweet. It just do it for you. So that's one of the reasons that I like it. But sometimes it cannot get the smaller and ampersand and less than and greater than, and these are the weird characters that we use to tell machine that what we mean. So we said that remove these things. So with the tidy tweets now, so we got the tweets, and so I commented this line because I don't want it run, but this reason is that I don't want to remove retweets. Otherwise, I could say that, hey, filter wherever you detected a text which this sign starts with RT. That's a research decision. Sometimes you are not interested to see retweets. You want to see original content. You will do that. But here I wanted to keep retweets. So, and then again, I mutate. I remove all text that has these patterns, smaller, greater than, and then this is a package called honest token. What it does, it generates some tokens, which means every unit, every word within the body of text, because we're going to work with the count of those words and things. And I call it strip URL, means to get rid of all the junk URL. And because it understands its tweets, it doesn't get rid of @ signs as punctuation and hashtags. Otherwise, if you use other type of tokenizer, they get rid of @ and hashtag. Then what I do here, I said that filter, because we got a lot of da, is, be, and they're really not very helpful words. We call them stop words. We said that, hey, this means a negation, so get rid of any word, any token which is a stop word. Remove all stop words which has like an apostrophe, and just keep everything which is alphabetical. Because, and again, this is a research decision, because I was not interested in keeping numbers here, because you get a lot of 2017. Oh, this is the most important word. 2018. Yeah, but if you are doing some text processing, you can forget this line.
So stop words is again another...
Stop words are the things that are very prevalent in the language, but they don't help us to understand the meaning of things, like the, is, are, am.
So again, all of these words are already accumulated in that.
Yeah, there are a lot of the dictionaries called stop words, and this package comes with its own stop words. I think it's used Snowball package, which was a package developed in C that has for many years used, and it has many languages that cover. So now we can go run this last 2 lines. It takes a little while, not that long, that it just make the text. And if you now look at the tidy text, so we have a tidy tweet. So the tidy tweet, what you have now for every tweet, which is we treat it as a document. For example, you see that 72, 72, 72, 72. You have words. So it tokenized everything. So these things were in that word. And it gets rid of stop words and URLs. So money, smart, week, libraries, their hashtag, financial literacy, library transform, providing kinds and certain things. So it breaks every document to its tokens. And it is become very easy right now, because now we can start counting tokens. Then we can start counting hashtags. For example, which hashtag is the most prevalent one? Which terms are the most prevalent one? And that's become very easy at this point. So, okay. So that was my data preparation step. So I clean up the tweets. I just turned it to a corpus of words associated with each document. So the next step, we're going to do some of those descriptive information, plots of frequency of tweets over time, frequency of hashtags, mentions, and terms. And here comes the beloved package called ggplot2. Names might sound weird, but it means grammar of graphics. So there was a book written by Cleveland. It was called Grammar of Graphics. It comes up with the way that how a good graphic should be built into components, and Hadley Wacom read that and was inspired, and then went and built a package that can generate very nice graphs and visualizations. So in usually a structure, we call it built of like multi-layers of things. So ggplot, you give it a data set, you tell it, hey, the x-axis is time created at, and the color, I just give it color red. And I said I want to plot a frequency plot, geometrically something. I put bandwidth 30, means that every 30 days I wanted to put it in one bucket, so I wanted to look at every month. And then I said that the theme that I want to use a minimal theme. So it is at the beginning might seems scary, but usually it's okay. We run it, but if you have to go down, because I'm using a markdown, you can see the plot here. If you run it, if you go at the end of the chunk, you can see the plot. So I really didn't put all the things because it got very cluttered, but so it is 2016, it's January, it's 6 months, 2017. So you get some spikes, and if you go look at the dates, so this is when the library transfer campaign started in October. This was National Library Week 2016, National Library Week 2017. This is again this campaign in October that we see. And then actually it is something else. I will tell you what is that later, and then it's when the data collection stopped. So I just want to show you simply, for example, in the election this morning when I showed you the plot frequencies, you saw that TV debates start spiking out. This is the highest of activity, and then you might see a disruption. Or like here, you might see something new happening, and then we will see that it was later, we will see that what it is. So we got that plot. So that was a basic plot, and I want to show you how easily you can just get like the basic data set you have with nothing else and create a frequency plot with ggplot. Then I also looked at the tidy hashtags, and I tried to show that you can use a floor date function. It's going to lump things within a month for you, and it can give you most frequent hashtags within a month. And if I just want to show you here, so if you look at the tidy hashtags and that code, it tells you that, for example, 13,000 hashtags was used in the October 2015, 17,000 was used in March, all of a sudden 100,000 hashtags was used in April, and it was like National Library Week happening, am I correct? And then it's just, so there's something very basic. So it's just, so that it's a 2 lines of code, you can get that. Okay, so we want to see what are the most frequent hashtags, top 15, and then plot them. So let's walk through, because we're going to do that. We said, okay, tidy text. Filter all the text when you detect they start with a hashtag. That means start with word with those tokens that we have. So what it does, it's going to go through this list, so that, hey, start with hashtag, no go. Start with hashtag, and just filter that. And then we said that, okay, count them, sort them, keep the top 15, and then I just mutate because I wanted to reorder the word based on the count, because we want to, when we plot, we get a nice plot of from the highest number to the lowest number, and then ggplot. So one of the beauties of tidyverse is this weird pipe function. So you can start piping function to each other, so that this is tidy tweets, filter them, throw the results into count, throw the results to the next function, and then when we got here, instead of, like, if you remember here in ggplot, I had like a data set. It just fed from the upper stages. So that, hey, ggplot, my x-axis is words, my y-axis is the count, and the field, the color, is the color of word, because I just have 15 now, right? And then I said that I want a geom column, the plot as a column. Don't put an, and then I flip the coordination, because this is for words is not interesting. This is might be more interesting. I just flip the coordinates and give the labels to the titles and use a theme for plot. So let's plot that. So I am talking pretty fast because I want to get to the content, but you have the code and you can inspect it later.
Is it all piping?
Yeah, it is. It's just using pipes. So I thought, yeah. It's so I plotted that. If you plotted that, if you go below the chunk, now you have another plot. So you can see these are counts of these are the counts of the hashtags. So this is a campaign for library transform. There's no surprise that it has this dwarf anything else. And you might make a decision, hey, I want to see other hashtags. So you might remove that and you sign that, hey, filter a string detect and negate that anywhere you will library transform, and you can get the rest. And you can see the distribution of things. And you might see some of interesting things here. So one of the things, okay, library transform, National Library Week. Oh yeah, sure, we know. National Library Week 16. Libraries, yes, sure. Save IMLS. Institute of Museum Library Services. A major body, a federal body that fund a lot of museum and library research. I was a recipient of their grants. And they are very important, but there was a proposal after the new administration came in to cut some of the federal funding for IMLS. Actually, they wanted to get rid of IMLS and National Endowment for Humanities. I think it didn't happen, but it created a lot of uproar. And it was interesting that people used the library transfer campaign to talk about Save IMLS. Usually that's when you deal with the text, you got a lot of generic things, and then in the middle of things, you start getting interesting. I didn't do a stemming. A work is something that you can do a stemming. Stemming tells that libraries and library are the same thing. It's the plural form of this. But for topic modeling, there's some research says that the stemming may hurt because people might use something in a gerund form or in a verb form and the past or present form, so you want to maintain that. Here we just keep that because if we were stemming these things and apply that to even hashtags, then it would be different. So library life, library, librarians, libraries matter, and I think it was connected with Save IMLS. They are facts, books, and there are some L word. So so that was a simple for the hashtags. So you can see. So you might say that. Okay, I want to see who are being mentioned the most within these tweets. So the same code, I literally copy, paste the code. I just change the start with hashtag with the start at a mention. So it's going to keep on tokens that have a mention sign, and I obviously change the title. So run that, and we got our top 15 or 20 librarians. So ALA Library, American Library Association. I love libraries. There was an account very active during this period. Dolly Parton, she tweeted about how she loves libraries, and then it was just retweeted a lot. Goodreads, Sherry Feldman was the president of ALA. Then you got President daughter, Ivanka Trump. So it was interesting. When you do the close reading, why people mentioning Ivanka Trump, then you see Save IMLS, and there was like people trying to reach Ivanka Trump so that tell your father don't cut funding from IMLS. And it was like interesting. But it was interesting that why this celebrity just all of a sudden showed up there. You notice that, okay, there's a lot of retweet and say, yeah, you know what, I don't want, because retweet structure is that RT at a user. So when it's tokenized, it gets a lot of retweet mentions. So what we can do, and if you remember, I mentioned there's a research decision. I told you you can actually get rid of retweets. So I copy the same text preparation line, but this time I didn't filter the getting rid of retweet. I called it tidy no RT. So we can run that, and then we can use this to plot again the same name of mentions and see whether there's a difference. Okay, let's run the next plot, and let's see whether. So the quick thing is that Sally Parton is gone because it was a lot of retweets, so the people didn't mention it. But Ivanka Trump is higher because people didn't retweet Ivanka Trump. People mentioned Ivanka Trump, tried to reach out to her so that, hey, libraries are important. And then there's a lot of libraries who were active, like Toledo Public Library, Worcester Public Library, Ohio. It's like, yeah, so there was a lot of public libraries being US IMLS account being mentioned because people were saying that Save IMLS at US IMLS is like a great source of funding. And then you can see how again, if you want to probably get rid of ALA library, because that was in almost many tweets, I mentioned many times, but you can see how other players are involved or engaged or being mentioned, per subject of conversation. So, okay, we did that. So now I want to, I think I forgot to plot that, but for the hashtags, there was a, so I want to go back to the hashtags and look at the frequency of hashtags over time, because it was important to see when the save IMLS happened, for example. So I picked the type 9 because there was a tie at the 10, so you will get 11. So the same thing. So we want to create a file called top hashtags, because later when we want to plot it, we want to say that just count the frequency of words in top hashtag column word. So I selected them, top 9. You're now familiar with mutate and reordering. I put the tidy tweets, filter only words are in top 9 hashtags, and then do the same frequency plot. Let's plot that. So we have to, so if I go down, I got a, so it is not a very, it's not a good visualization, because we want to talk about how we do it, because if you want to see things, you have to get rid of these very big spikes, which are like library transform and National Library Week 2016 or National Library Week 2017. But save IMLS happened during this period. This is when it was mentioned in I think March and April 2017 that federal government gonna completely shut down IMLS and National Endowment for Humanities, and that was, people started to get some activism and get engaged to support. So you can do the same thing for mentions. Again, you're gonna extract top mentions here with the same code, very similar, but instead of 9, the only things I did is start with that hashtag and top 15, and we extract the top codes, and then the same thing. Tidy tweets, filter words where they are in top mention, and this means the column word, because if we open that tidy tweets, so you have a column word. When you say that square bracket word, it means that you look inside this column. Yeah, we plot that, and then you start seeing that again, ALA library, but I was interested in, Ivanka Trump was here. It was during that week, then the campaign of Save IMLS was happening and by being mentioned. So this is a very simple case, and that we looked at. Initially, when I started looking at the data, when we were doing it, I had no idea, and then I started reading about it, and then talking with colleagues, I learned the context, who were librarians, that tell me that they were engaged in this campaign, they had a lot of contextual information. And you see that US IMLS was kind of mentioned here before people find out they have to reach out to like president's daughter to save IMLS. So I want to show you that how easy it is. And the good thing about the code is that, and that's why you should learn to code instead of using point-and-click software. You write this code and you use it 12 times, 100 times. Oh, new data sets, just I'm going to change the name of columns and bum, 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 bum. You just run it. Because that's going to be, that piece of code going to apply to any type of Twitter data. You just need to change the input-output. Someone told me that learning coding and point and click, the difference is that you're traveling to a company, like say they go to Japan, and they bring you a menu for food, and they have photos, and you can say, I want this. But if you know how to code, it means that you learn Japanese, you can read the ingredient and make a very good decision, because sometimes the photos are very different from what you can eat. It's super hot or something else. Okay, so that was about the hashtags and mentions, but we want to say that let me see which words are being mentioned the most. So what we are not interested, we get rid of, we said that, okay, let's create top terms. So all the tidy tweets, get rid of hashtags, those started with hashtag mentions, and if there's an RT, we don't interested to keep that, then count the words, sort them, and keep top 15, and reorder that column based on their number of frequency. So we create that, and then we can apply the same thing to plot. So just remember, we already removed the stop words. So if you don't see a lot of I, the, or am, is. So obviously, library is weak, and then people are happy. And they're top. This is National Library Week. At public library, people learn about stories, story time. You know, if you have a toddler, you always take them to the library for a story time. Librarians, the second most trusted profession in the U.S. just after nurses. You give your life to the nurses, then your brain to our librarians. Celebrate National Library Day, school, love, books, visit, and if you go there, you see the kids, children. So it tells us, it doesn't tell us direct things when you go to topic modeling and other things, but it seems that what terms people associate with libraries. It is like story, happiness, love, books, kids, all good stuff in life. So that was the top terms, and then if I want to see their frequencies, again, we just use the same plot, and instead of top mentions, I've said that, hey, look into top terms now, and the rest you just go change the titles. Otherwise, it's the same code, and it's look at per month because they have a bandwidth of 30. Okay, so it's a terrible visualization. I apologize because you have to work on your visualization if you want to make them really nice. But again, you have a lot of terms that you see like books. Yeah, they appear a lot of times. So library week, visit, top, and all the stories, and you can see them how they are distributed over time. So I want now show you something. If you come at the beginning of this chunk and press this button, it's gonna run all the code. And then it's gonna generate all of the graphs that you want, because every time you run a piece of chunk, it's gonna replace the output. And you can have all the graphs here, you can go through them. And why it's matter, let me save these. No, probably it doesn't work. Oh, does it work? So the report that I showed you this morning, it just had text. Now, after every chunk of text, I have the graphs. Okay, I did this work, it gave me this graph, and I run this, and I got this graph. So that's the beauty of our Markdown documents. You write, you have all your outputs and code, and yeah.
How did you get that? Ran the whole chunk?
No, so I ran the whole chunk, and then there's a preview button. When you click the preview button, because every time you save this file, that HTML file you had in the folder, it's going to be updated with the outputs. The good thing about R Markdown is, especially if you do a lot of work, for example, you need to train a model, it takes 2 days. You came back, you save the model because you don't want to spend another 2 days to train it, and then you work on another piece. So every time if you get an output and save it, it keeps the former outputs. You do not need to run it again. It just adds the new things. It is so good. So I am evangelizing our Markdown notebook. You can write your journals and memories in our Markdown. Okay, so that was the descriptive basic things we do. So now we can just go to next, gear up, go to the next phase. Let's see that if we want to see which people are being mentioned together in a tweet, whether there's an association between them, or which two terms are being hashtags associated to each other. So I wanted to also get a peek into Quanteda. Quanteda package, it's an extensive package. It has a lot of nice codes that you can go get. It can also conduct what we call it latent semantic analysis. That's different from topic modeling. Topic modeling is a probabilistic approach using something called latent Dirichlet allocation. But latent semantic analysis try to reduce the structure of those like document and a lot of terms to some, let's say, reduce it to a few major structure of word co-occurrences, and those can be understood as semantic structure beneath that corpus of text. We are not doing LSA here, but with Quanteda you can do it very easily. There are a lot of nice things, but I want to quickly show you how you work with Quanteda a little bit. So most of other packages beside tidy text, they used to build corpus. For example, there was this packages we used back in the days called TM, text mining package. And then there was text2vec, which is also another. So they create a corpus, which is an object, an R object. You tell them, hey, this is my data set. Where is your document ID fields? Because every document should have an ID. So that tweet ID. Where is the text field? So that the text column containing my text. And then it builds a Twitter corpus for me. Then it creates something called DFM. It means like data feature, document feature matrix, which is actually a document term matrix. What does it mean? So imagine a matrix that every row is a document and every column is a term you have in your whole corpus. And for each cell, it tells how many times that exact specific word appears in your document. So it's going to be a very sparse matrix. Why? Because you probably have 3,000 words in your corpus, but you have 10 words in your document. So in this document is going to be 00001, 0002, 000 till the end. So that's what we call it document feature matrix. So it has a nice function. It creates you get tweet corpus, and it has some things built to it. Hey, remove punctuation. You can remove URLs. You can remove rewrite the regular expression, so that what sort of patterns I want to remove. I just put remove punctuation here. If you comment this line, remove the hashtag from the beginning of it. So you can see the head of this document feature matrix. So let's run. So let's. Quanteda is already, I think, loaded. I think I had it. So we create a tweet corpus. If you are interested to see what type of beast it is, we can certainly look at it. It is a list. It has all documents, which has like 63,300 something dimension, which is the tweets, and one column for text. Then you have metadata. This is metadata for every, I think it's document ID. There's a setting, there are tokens. So for each document, it generates those tokens, which was those columns in tidy text. So it is a different way of building your data set. Okay, if I want to show you this, I can actually run, because it's gonna show it in. If I just run head, it's give me the head of that. Oh, I haven't built it yet, sorry. So now we had the tweet corpus. I have to create that document feature matrix. It's gonna take a while. You got document feature matrix. Let's see the head. Okay, I forgot. Head gonna be showed under the chunk, right? It said that document feature matrix of 6 documents, blah 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 features. There were like 52,000 features in this data set. So you can see this it's 100%, almost 100% sparse. It means that it is almost 100% zeros in the cells when you get it. Okay, so the rest of this thing, so it has a very convenient feature that you can tell that I want to extract hashtags from this document feature. You can select DFM select. You have the tweet DFM data, and then the pattern is that anything hashtag. So I can select features for each document that start with hashtag. For example, if in a document there are 2 hashtags, it's just going to keep them and get rid of the rest. And then I select top features. I said that top 20. You can take a look at the head, and then it has another function which called feature co-occurrence matrix. So it has all documents. It said that like save IMLS, hashtag National Library Week, hashtag library transform. But you're going to turn it when we create a feature co-occurrence. It's going to say like library transform hashtag save IMLS, that's a pair. Library transform National Library Week, another pair. Save IMLS, National Library Week, and so turn it to 3 pairs. Why? Because we want to create a network with nodes. We need a beginning and an end for each node. So that gives us that network that we want. So we call it feature co-occurrence, the things that co-occur together. And then when we get that, we can, there is a text plot network function that's going to generate a network for you. Another thing is that you can get that network and visualize it with another tool, because there are limited options that you can manipulate your visualization, and you will see that these visualizations are not as fancy as the ones that you have seen this morning. So we can do the same procedure for mentions, and that will help us to create a network of people who have been mentioned together in the data set. So let's run through this until the text plot and see what we will get. So another things that you can do with RStudio is that if you select a whole bunch of lines, and then Control Enter, it's going to run all of them. Okay, let's see what we get. So because we created those feature co-occurrence matrix, which was a co-occurrence of hashtags, it created a network between different hashtags, and we only looked at top 20, right? And then the link, the strength of the link between the 2 hashtags means that how many times they co-occur. So there was a strong association between them. So library transform is the center of universe, because this was a library transform campaign. And then, for example, it was National Library Week 2016 was mentioned, National Library Week strong, libraries was big, library was big, and also Save IMLS was a, is it okay if I touch this screen?
Yes.
Okay. I said I don't make it like, you spend like $1 gazillion on it and then they just destroyed it. Yeah, library card sign up. So these are the things that you can associate themes that people use around library transfer campaign, and whether that might be interesting for you. So we can also do the same thing for mention networks.
Question.
Sure.
So in this network, the thickness of the line represents the frequency?
Then they co-occur together. For example, there were more tweets with library transform hashtag and National Library Week together appear in one tweet. Is that clear? How many times they co-appear in one tweet? So we have almost the same things for the user and the mention. So what again we did is select everything that has the start with a at mention. Then I select the top 30 users here. Then feature co-occurrence matrix. We created that. Then we used we select only those those 30 top users, and then we plotted the same thing. So let's run that as well. So we got a new network. So if you want to really get good visualizations, you have to extract these networks and take them either to other packages for visualization, or a tool called Gephi, which is very good at visualization. That makes you a lot of control on the size of the nodes, color of the links and other stuff. You can also do it in R with other packages. So, our celebrity is mentioned with LA Public Library. So, NYP, Ivanka Trump was not mentioned with anyone else. But she was mentioned a lot, but it was not associated with anything. So it was like US IMLS was mentioned with Sari Feldman was the president of ALA, Toledo Public Library, other places, but no one was co-mentioned with Ivanka Trump, but she was present in the big data set. And Goodreads was co-mentioned many times with I Love Libraries. That's a very active librarian user, tweeting gazillion times and being retweeted many, many times. And because this data set also included all retweets as mentioned, so you need to get rid of retweets before actually doing this if you want to really get people who are being mentioned in the text. That's interesting connection. So yeah, so these are some of the things that you can. So.
Does the position of a node mean anything?
I mean, I think they built like a force-based algorithm at the, behind this. So they try to get the nodes with most connection at the center, the nodes with least connections at the periphery. But I don't know exactly what library they use. Okay, so we went through the basic descriptive things. We did a little bit of network with terms and topics. And 45 minutes is usually when the brain starts to going different places. So why don't you get a biological break and stretching and releasing and mediating like for 3 minutes or so. And then we're going to go back and talk about topic modeling. Sounds good? So how many minutes do you need? Like, yeah?
So what you said, like you said.
And I think we have until 3:30, right, for the total thing. So, it is not 45 minutes. It's more than an hour. Sorry. So why don't we get like 6 minutes? We will be here sharp, 2:50 to run through.
So will you be talking about how to access the treated data?
No, but I can talk, not here, but I can talk with you after. Yeah, and I can also show you how we did the Twitter data collection through a tool that I provided the link in the document. It's called DMI-TCAT. Yeah, it is in this document.
Oh, okay.
Yeah.
Towards the bottom, toward.
I will show you.
Oh, okay. So basically, all you didn't script the data from the Twitter.
No, we didn't, because according to Twitter's term of service, you can't scrape data. It's illegal. However, that there's a case in the court now that might change.
Okay.
We got the data from Twitter API itself.
Okay. And then the package that you mentioned, whatever the name is called, that's basically taking advantage of that API.
And there is a package Twitter R, so you can get the data from Twitter API, but we use the system which was more elaborate because we don't have the it's called DMI-TCAT.
Okay, and it's in the R file.
Yeah.
If you want to.
But then we install it in our AWS. It was pretty easy. It has a script. You just run it, you download everything, install anything. It has a graphic user interface, and it just we can let it run like 50 million tweets.
Oh.
It's always good to.
And also, you we were talking about the network analysis. I know you mentioned at the beginning we were briefly about the network.
Yeah, today not that much because it was focused on text. But I put some links to some of the packages that you can be able to use.
Do you offer other workshops?
Oh yeah, Elizabeth.
I did it a couple of years ago, and maybe I was a faculty, but not recently. Yeah.
So now you are mostly focusing on the text analysis?
No, I used to. I do also network analysis, but I haven't done a workshop in a while on network analysis.
Thank you.
Sorry.
So you have to create a loop
I think she's from
that appends every 15 minutes of running the computer.
Wait, because I know she's a library student, but then she like, how many Jersey? No. Yes.
I'm not sure if you
Oh, go ahead. That's mine. Yeah, so my last name is Mao, and so that's like chairman. We don't have it. It's just a common last and so you would just hear like a few months. Okay. What, this weekend is some events in downtown. Have you heard of that? Yeah.
I really wanted to go, but I couldn't one of my friends.
It's a 4-day event. Pick one day. Yeah, so Thursday, Friday, Saturday, Sunday. Yeah, so every day, like the life will always be there. So you've never been to one? Yeah, I went there like 2 years ago in downtown. Nice, nice. And then so like a Washington Park. It's like exhibit. So it's like down in Kentucky and then. Yeah, it's pretty cool.
So if I go like once, Tuesday, I will follow it.
If you like, and also even if you have a car, maybe a lot of people are close because they have like parade and stuff. And so the best solution would be like take the shuttle or bus and down there, and you could just stop at the Washington Park, like music hall.
No, I haven't been on it.
Yeah, I mean, look around, like
That's one thing, but I don't really know anyone. And it's just, I think, I think people understand, like, it's really hard to maybe it's right here, and if I have so much stress, like,
especially PH.D.
sometimes when I get very back, I just like, it's socialized, but I don't know.
Oh, sorry, I misspelled the name. Yeah, so, how do you the done? Oh, not. Okay, sorry. Yeah, let me just. The done. Yeah. Alright. Thank you. Yeah. Yeah, I mean, and if you need, line stuff, yeah, I mean, because I don't have a car, just Monday through Friday. If I work, I probably won't be able to.
That's okay.
Yeah.
It's like, even my summer classes,
But it was so
I've never posted that, but I will be. Yeah, and also message.
yeah. I don't know if it's like I mean, I have like, I mean, you can go like these for Instagram and Snapchat. So my like friends are writing stuff. So it's like more social. And Facebook, but I mean, both platforms.
You really need to invest in space and I guess the space.
I mean, I text, so text message will be the easiest way to reach me. Yeah.
there's a space going in forward because in terms of services, you cannot if you're a faculty, a lot of people, but if you're a faculty, you probably there's a core space in Washington DC. Actually, the faculty from the University of Michigan, Cincinnati, and other faculty.
Only today, right?
But a lot of companies were
Some say
kind of
that they are busy, some say that they're out of town. I accept some doctorate job.
the idea was that if you arrive also,
And then I see that one of the teachers was a doctorate. Yeah, so that we plan to like have a drinks afterwards, but it's just, I mean, it's just I decided, literally 2 days ago, I looked at I but other than, I'm available, I'm pretty much all available. I mean, it's like I don't really, no, these are no supervision.
Like the lunch. Have you? Okay, so I guess 2 years ago. Oh, okay. I didn't go there last year. Yeah, like in downtown. Yeah.
Yeah, but there was a library.
I mean, I plan to go like on Friday, but before that I have a meeting until like 7 or 8. So like, yeah, I mean, I do have like a goal, like, sorry, but no, that's but yes. So Friday, Saturday, and Sunday, and Thursday as well. So yeah. So I mean, because and also I'm planning as well. But then yeah. But if you are there like on Friday, just send me a text because like Friday I would probably be there. That's just a bunch of friends, and then we had a meeting like a schedule. So that's why it's been scheduled. So sorry, but I'm just saying like if I'm new here, that's something to check out.
They built this very strong like GPU-based database. They were getting all the streaming data, and they had like they were visualizing like 120 million tweets or like real time. They were actually people who were working at GIS data. They were interested in geographic data, so they wanted to have their GPU-based database. I think they changed their name recently to another thing. It was a startup came out of Harvard and MIT.
Yeah. I probably will be already in downtown.
Okay. So we are getting to the exciting part, which is topic modeling. So I tried to go through the topic modeling, the first section, hopefully that you can get a sense of how topic modeling works. The next section, you might have to run it on yourself, but it has the explanation. It is that how we can run topic modeling with different number of topics, because there is no deterministic way to come up with certain exact number of topics in a corpus. You have to set okay, let's go with 5 topics, 6 topics. And that's a probabilistic method, so that's why every time it might give you different things. Generally speaking, topic modeling is a type of statistical unsupervised modeling that allows you to discovering abstract topics. And I said that what do they mean by topics? In a collection of documents. It's heavily used in text mining and many practices to identify underlying semantic structures. There is a paper called An Introduction to Probabilistic Topic Modeling by Blay for HCM communication. He was the person actually invented topic modeling in the early 2000s, I believe. It has a lot. It is okay, but might have some math. But Ted Underwood, he's at University of Illinois Urbana-Champaign. He's a digital humanist. He also has a nice blog post. I forgot to put it here. I will add it here later. If you come back, you will see that. Theodore will try to explain it in plain language. What does it mean? But in a nutshell, the idea is that let's assume that this corpus of text consists of different topics. And topics, each topic consists of a group of terms that co-occur together or has a tendency to appear together. For example, the idea is that if a book is about physics, you might see the terms quantum, mechanics, electrons, relativity, and these sorts of terms. And you have a whole bunch of books about biology. You might say that cells, mitochondria, I don't know, this set of terms. So you might associate, okay, these terms are about biology, and those texts that these terms or these topics are associated more with are texts in biology. But how we come up with this, the idea is that we said that 7 topics. When we said 7 topics, we believe every document we have has a probability distribution of that topic. It might be 0.0001, which means that that topic probably does not exist in your text, but very unlikely. And so we believe every topic, if you sum them, the presence of a topic in a document, it's summed to 1. So it says that how much the proportion of this document associated with one topic, and we decide how many topics. And then for every term in your corpus, we said that they have a probabilistic association with that topic. It means that if this term is 20% has the probability to appear in that topic. For example, if it is like about biology, you have cell, this term 70% might appear in biology text, and probably 2% appear, or 5% in a physics text when they're talking about battery cells, or something like that. So when you sum all the terms in the corpus, it also becomes to 1, which means the probability of 1. Our model starts at some point with a random allocation of these probabilities and try to go through the texts and check, hey, text, I open you, what's the probability of this text, these terms appear to you, it updates its probability distribution, and keep doing it until it converges, and you cannot reallocate probabilities again. So, and then you come up so that, hey, we have from these 7 terms, these 7 topics you picked, these terms has the most probabilities to appear, and for document 1, topic 2 has like 60% probability be the topic of this text. So it is a bit complex, but it's a probabilistic way to associate terms with topics and topics with documents. So as we go through it, you will see more. So there is a method for this whole process. I told you that you start from this random distribution and then go back, call it latent Dirichlet allocation, LDA. There's a package in R which is really nice, and I call it, I started using it back in the days. We were using the package called topic models, which was actually, I think, an interface built to a package that the author of probabilistic topic model wrote. But STM, which is a structural topic model, has 2 innovations. First is that it does topic modeling, plain vanilla topic modeling. Hey, it means that I'm talking a lot. But it also, the innovation that it has, it also can include the metadata you have about each document as a regression form into this including into these topics. What does it help us to get? It tells us that, for example, if you have different authors with different political affiliations, you can see which topics appear with each author. And it said, for example, an author keep writing about immigration, or an author write about healthcare, if you study like political blogs. Then you can see that whether if you take into account their political affiliation as a category, there's a significant difference between the topics they talk. Or you can show how the topics are like a word cloud of the topics they use. Another use is that if you associate every document with their time, it's a metadata for time. When it's created that, for example, tweets, it tells you how frequency of a topic change over time in the corpus of the body, which is very nice, and that's very powerful. Here we don't use any of that. We use a structural topic model for its plain vanilla topic modeling because it's written in C++ and it's very fast and efficient for even doing topic modeling. And so I want to explain that a structural topic model package has a whole set of tools for preparing texts. So do you remember we prepare text with tidy text? It creates similar, and you can also feed into it a DFM, document feature matrix from Quanteda package that we just created the networks. And it also had its own, so you can give it all the tweets. Let's say create a corpus, it create documents, it create IDs for them, and you can do that. But here, because I was going with the tidy text framework, actually the tidy text package author reached out to the structured STM package, said, hey, you are doing this great package, can you just get data in tidy form? And they said, sure. They added the feature. So you can now actually feed that tidy text data that we have, and you just need to add some things that I explain. So it is the same process that we used, but in this case, I got the tidy tweets. I get rid of hashtags, and I get rid of mentions and retweets, because I didn't want major topics to be all the hashtags we already see. And then, so you have to add the counts of the words, and then I filtered anything which was less than 50 times appearance. And again, this is a research decision. You can go lower, you can go higher. But the rare words that just appear 5 or 10 times in your corpus, they don't really mean anything. They get very low probabilities. And then there's a called cast sparse, the function that create that sparse matrix that you can feed into STM package. If you want to use the Quanteda format, it has also another package called cast DFM. It created in that format, and you can fit it. But I try to go with the tidy sparse tweet format. So what it creates, it's going to create a matrix of all documents, the tokens, and their frequency. And we filtered hashtags, mentions, RTs, retweets, and words with occurrence less than 50 in our corpus. Training topic models takes a while, because it has to start, as I mentioned to you, it starts a random allocation of topics, words, terms to topics, topics to documents, and go through again and again till the model converge. And then we can let this model run. Do you want me to let it run, or I can load the model? I think I can load the model. It's kind of fast. So what I did, when I run it, the other day, I created this object topic model. There's a function called save RDS, so it's efficient R data format. So I saved my model, and there was a folder in your project folder called models, and there are 2 model objects there. So the good thing is that you're working on a project, you let your computer run for 2 days, you train the model, hallelujah, you close the R, go home, and then you have come to pull your hairs because you have to let it run again for 2 days. So usually it's a good idea to save that model object as an RDS, and you can immediately load it. So that's what I'm going to do. But here in STM, I said that, hey, get this tweet sparse matrix, k equal to 5, means look for 5 topics. And Vorbis said you can say that it can show you how much progress it made. You can see I just made it false here. And initial type is a spectral. There are different ways that you can do the first initiation, and that's the allocation of the topics to the terms. Authors of the package suggest a spectral. It's yield, because this is a probabilistic process, not deterministic. Sometimes you might get different things if you start from different point. But with a spectral, you not 100% guaranteed, but almost always you get the same thing, and it's pretty good. So they always use that. There's a Gibbs approach for the Bayesian sampling that you can do as well, and you can even define your own way. But the suggestion is to go to the spectral. It's provide the best results. To just show you, you can go home or later after that, you can let it run. But for now, I go to the models and I click on topic model 5, and it said, you want me to load this? I said yes, load it. And now I will have you can have an object topic model 5, and if open it, it has a lot of Greek letters for you. So betas are the coefficients that are associating with defining that how much is the probability of a term to belong to a topic. For example, if a probability of beta for a term is 0.03, it means that it's 3% probability being associated with topic 1. If it is like 0.3, it means 30% the probability. The other thing that you might be interested are the gammas. The gammas are, you have to go extract them. So they are associating the topics to document, if I get it right. So I might not. So let's look at so imagine that we have trained the model, you have the model, and then I want to extract those. So there's a package which the whole thing happened because of there was a tidyr package and part of dplyr. Now you have tidy. Tidy gonna get nice output of that list that you see, the jumbled list of things. Extract the coefficients for you, give you tidy betas. So I can extract that, and we can take a look at the head of that. What was there?
I think it's called like topic model 5.
Oh, you're right.
Actually, you can run the whole chunk because it doesn't take much long.
Just
run it.
Really?
Yeah.
It takes 10 minutes on my laptop.
Okay, my laptop is good.
So is it on your laptop or you're on server?
I'm on the server. Yeah.
Oh, server is good, not your laptop. So let me, it is, okay. If I knew, I would run it.
Yeah, it took me less than a minute. So.
Okay, so yeah, we can do that. Oh, that was topic model 5, I should have checked, yeah. I forgot that. Yeah, we can let it run, but if we already run, then the RCD server might have a different time. Oh, it's done. It's so fast.
So that's what I ran the whole chunk.
And my laptop has like 232 gigabytes of RAM and 8 cores. Actually, you use 1 core, but it's
Yeah, I ran
that was okay. Let's go see. Take a look at the tidy. So I got the tidy beta, and then I will run. So if you go to take a look at the output. So it gives the coefficient of for topic 1, the term children, that it has a coefficient. It is e minus 17. It is 10 to the power of 17, minus 17. But you see here, for example, topic 2 with space has like 8, 10 to the power of 3. So these are very small because you have like 50,000 tokens in your data set, so you have to redistribute the probabilities, but some of the things get bigger probabilities. So you can see that for different topics, like children, its relationship with topic 1, 2, 3, 5, and 5, 1, 2, 3 to 5, and space. And for every term in your corpus, it gives a probability of association, being associated with a specific topic. And the topic is like a whole bunch of terms that used to co-appear together. That we talked them. Okay.
Excuse me, what does the number represent and what does the text represent?
The text is a term in our corpus. There was a column called topics. Topic number 1, we decided to go with 5 topics. We said a term children, and it shows that it's a probability of association of the term children with topic 1, or the coefficient of its association.
What does topic 1 mean?
Topic 1, we have to take a look at it to see what does it mean. We said that assume there are 5 latent topics existing in this data set, and if we want to cut this data set into that 5 topics, what those topics could be.
Okay, meaning to the topic.
Yeah, so let's take a look. So what we're going to do, we're going to look at this. We got all these, coefficients. We look at those coefficients. We group by them by topic, like topic 1, and we will pick 10 top words with the highest coefficient association with topic 1. And then we're going to again ungroup them, and then we do some cleaning to like mutate, because you don't want to see 1, you want to see topic 1. It makes things nice, and then feed it to ggplot and tell ggplot to plot it for us. And then I'm going to create a FAST trap for each topic. You see what terms are associated with that. Okay, let's run this. So this is when it starts. That's an iterative process. That's why I said that we don't know, because it's probabilistic. So topic 1. So the terms that are associated with the highest coefficients are like, and you can see the association. For example, the beta for this topic 5, library, has like 25%, and it's very strong there. So topic 5 is library, libraries, librarians, week, celebrate day, visit, read books, dear librarians, we will visit, something like. So that is very library centric. I mean, almost everything. Topic 4 is like story, happy, students, reading, life, funding, local, transform card. It's like a context of local life and library in the context of life. This is about like library celebrating. Again, it's topic 1, top, happy, a story, love, a school, a stories, Twitter, communities, literacy campaign, impact of libraries. I will show you later, actually, if you want to get a good number of topics, you have to go for 20. So 5 is lumping many things together. For topic 2, national, public, people, lives, free, books, learning, goodie, time, awesome. Again, national, public, people, lives, free, book, learning, all the time, awesome. So good all the times. So that's what we have done to see the terms association with topics. Now we want to look also on association of topic probabilities of each document is generated from certain topic. So we look at which terms are associated with topics. Now we want to see which topics are associated with documents. So which topics the tweets are talking about. So then this is the time that we're going to look into gamma metrics in the topic model. So again, we're going to tidy that up to get a sense of that. And let me just show you ahead of that topic. So what does it says? It says that document, this is a tweet ID, whatever, very long tweet number. Topic 1 has 14% association. So it's a different tweet. So it goes for the topic. You can sort it based on the document. So topic 1 has a 35% association with topic 1. So this one, 45%. So most likely, the terms we saw for topic 1 are associated with this document. But you can here see that, for example, this tweet is just 4% associated with that. So there are like wide range. So when you get a confidence, a very high confidence in one topic, so one way that you can decide what the topic of each tweet, you can sort it based on the document and see which topic has the max value of gamma, and then associate it as the key topic. Actually, that's what we did for the high-care paper that with Mark we wrote. So we look at people's topic modeling and then extracted the topic that they were talking about.
How is that different from the frequency plot that we just did?
So the frequency plot is just look at the frequency, but this is different. Let me give you this example that Ted Underwood just said that. So that we have a set of documents. They are about like a Congress committee, and they're talking about leadership. So you see the terms organizing, managing, and LEAD, lead, right? There is another set of documents talking about Flint, Michigan. They're talking about contamination, water, LEAD. That means a metal there. If you look at simple frequency, this is the same term. But when you use a topic modeling that understand because of where this term appeared with set of other terms that's talking about the metal contaminating water, that talk about leadership. So that's why topic modeling is better than just using the simple frequencies of terms and association.
You're not talking about the very beginning frequency of them. You just showed.
That was the betas that I showed. It was the terms association with topics.
Okay.
This is topics association with documents. It means that, for example, that specific document is most likely about topic 1, not topic 5. And sometimes when your two topics are very close, it's kind of their level of exclusivity reduced, because they kind of have like, it is 40% about this and 40% about this, because these two topics are very similar. So, so what we're gonna do, we're gonna just again prepare the gamma terms, and then, okay, I forgot. Okay, so I'm just, this is a library for a nicer theme for plotting. I'm gonna prepare my, again here I get the top terms for each topic. So we look at TID beta. Do you remember they have different probabilities of association with topics? I got for each topic the 10 most important ones. And then for the gammas, I just prepare them, and then we're gonna plot. This is the important plot that we want to see. So what does this shows us? That topic 1 is the most prevalent topic, almost in 40% of the documents, and these are the words, top 10 words associated with it. Then it is topic 5. So this like top, happy, story, love, school, and then library is everything. So these are the two prevalent topics, and then it goes back, topic 4, topic 3, and topic 2. These are kind of very similar, and if you look at these two, they are kind of the same thing. They kind of, and that's why. So the only difference, like oldie goodie. So they're kind of one topic, but so one of the reasons is that we used not enough number of topics, and I'm gonna tell you that why that matters. And so the last piece, if I want to show you here, is that you can also plot all the topics and the probabilities and the terms that you can see. Let me just plot that. So it was like topic 1 expected proportion is like 34.5, and these are the top 10 terms, and this is actually what we just plotted. So that's in a table format of the same thing. So we have just 10 minutes left. So I want to say that always what you do, you're going to explore different number of topics to find the best topics for your case. So I just come up with this arbitrary number. Let's say, okay, let's say 5 topics, 10 topics, 15 topics, 20 topics. There is a function in STM package called search k. It can range for a search of k numbers that you gave it, and it comes with the best number for you. But because we were using this topic modeling framework, tidy text framework, I tried to do it through the tidy text format still. So I said that, okay, I'm going to want to look for different Ks. There's a package called FAIR. It can run use multiple cores. I don't know how it works on the server, but on laptop it works. But I also have the file, so if you can let it run in the background. Yeah, it's run. Okay. So because that might takes a little while. So and then we tell it, hey, run a topic model, and this is a nice like functional programming in R, you can say that this is the function that I want to run, this is the k, so it goes and run it with different k's, k, 5, 10, 15, and 20. And then we're going to create a holdout set to evaluate our model. The holdout set is that you're going to remove some of the terms from a tweet and tell the model predict them. And if it has a good prediction, it says that, okay, it understands the topics well. So that's one of the metrics we're going to use. Then there are different metrics that you can, if you use the STM package itself, it's very easy. So the exclusivity. Exclusivity means that how much these topics are exclusive to specific documents. So when you have more topics, it's easier to have more exclusive topics to the documents. When, like over us, you lump just 5 topics, they are very generic. But another metric is semantic coherence. Semantic coherence is that how much the terms within a topic appear always together within a document. Semantic coherence works very well when you have distinctive topics. For example, you have literature on physics and biology. So you have terms always appear with each other in biology and terms appears always with each other at physics. But you might also get high level of semantic coherence when you do few topics. If you do 5 topics, it's going to go pick generic terms that appears everywhere together and create your topics. And that was the case with our 5, like libraries, networks. So you get high level of semantic coherence, but low exclusivity. So one way to look at this is to actually look at different level of exclusivity and one dimension, and semantic coherence and exclusivity, and you want everything. The best number of topics is up here. High level of semantic coherence, high level of exclusivity. But that's hardly come around. Probably you get something in middle with high level of exclusivity, and because always if you have like with 2 topics, it's going to get a lot of generic terms and high level of semantic coherence, so it's better to play with it. So so I think we have to go to plan B here.
Yeah, it crashed.
Oh yeah, I hope you didn't crash the whole server. So we have this object called many models. We can load that. If you go to that, okay, many models is up and running. So let's run that many model. Okay, so we have the many model. Let's assume that is running. So we need to create our hold.set because we also test hold.set as a way. We extract all those features. If you use the STM package, it's easier, but because we wanted to do it tidy text, we have to do, calculate bound and residuals and other stuff. So residuals means you want always residuals below. High level of semantic coherence, high level of exclusivity. Then we can see the results. We don't need to see the results. Because I want to run to make sure that we got this. So this is this diagnostic plots that we got. So as you can see here, so the 5 topic, it did poorly on hold.set, has high level of residuals, but semantic coherence was high, but the lower bound is lower. So when the model converges, it tries to go like that. So the higher here is better. So with 10 topic, not that much of improvement. All of a sudden we go to 15 topics. We got much less residuals, getting much better prediction, a whole lot likelihood. We start going up with the lower bound. Semantic coherence is at its lowest. With 20 topics, we getting less residuals. Hold.set is even better, and then we get a better semantic coherence. So 20 might be a better option to run because the corpus was big. So we don't want to just lump everything to 5 things. And if I plot the exclusivity, okay. So now I plot for each topic exclusivity and semantic coherence. So you see the 5 topic has the higher semantic coherence. It appears 3 of them here, but they are not very exclusive. They are very generic. With let's say 20, you got a lot of exclusive, but some of the topics are also show a good level of semantic coherence. 15 is also very close, but it seems that 20 is better. So 10 does not give you, it's kind of not very good in semantic coherence, but it's a little bit lower on exclusivity, so it's better to go with 20. So that's one way that you can play with different number of topics to come up with that. And then now, for example, as an exercise for yourself, now you got topic 20. Pick that model with 20 topics, and then go and extract the terms and betas, and then plot and see how they are different, which terms you got. So that was the plan what we had, but there are also other tools and packages that you can use. Topic modeling, with the text-to-vec and topic model, there's a very nice package called LDAVs that generate very nice visualization. If you have a couple of minutes, I can just let it run, and you can see that. There's another package called UDPipe, which is using a universal language model, and that good thing is that you can use it for many different languages, with like Persian, Arabic, Spanish. And the other things that UDPipe has that you can say, I just want to do topic modeling only on adjectives, because it can identify part of a speech. So that only topic models with adjectives, because you're interested what type of adjective being used, or only on nouns, or only on verbs. And that's pretty powerful. Yeah, we did a paper for LA's conference, a poster for LA's conference based on this data set. We have also a Shiny set. We also use the same methods for the report that we did for the Poland, for the Iran election, and the work that we have done in Turkey. So it was the same set of toolkits being used. So that's what we had for today. Feel free to use that content. I said that I will put something, Ted Underwood workshop into that document. You can come back to it and see that. We have 1 minute. Do you want me to show the Shiny app? Or, okay.
Is that like a front end for the analysis? Is that the Shiny?
Yeah. It's actually Mark did all the tortures that he went through. So we had a whole bunch of other I hope it runs. So you can, with the Shiny framework, you can build very nice interactive tools. So it has a hashtag and mentions, co-occurrence of them, and topics over time. So, for example, here is the frequency of tweets or things that, and then you can just change, and so you can interactively play with things. So, Shiny app make it really easy to do this type of work. You can define like how many mentions that you want to see. This is the same ALA data set. We have like 10 mentions. We can add it to like 7 mentions. We can change the range. And it just automatically updates all of these things. So you can also build networks of things. It's not a very nice visualization. You can also do topics over time, and it's a topic modeling that you can see that with the 5 topics, and you can just shorten the period, let's say. So. And then you can see the topics that are happening during that period. And this is a different type of visualization that you can see them as streams instead of being stacked on top of each other. And then we've done it with like topic densities with 5 topic, 10 topic. then you can see it. So this is the same code in behind the set, but one of the tricks was that you do the analysis once, create all these objects, and then cache those objects and just visualize them. And it's very fast. Otherwise, every time you want to run a topic model, going to be tough. We also had these topics. Is it the object or no? So this is LDAVs. If you have a better, so you can define different metrics. The number of clusters, the number of terms, and it show you a nice visualization. It's on a bigger string. So, for example, if you go on topic 7, you can see which terms at the time we did a stemming. So, for example, together become to get, and celebrities become celeb. So you can see that which terms in topic 7 and how much is that term associated with that topic. It was nice, and then you can lump topics together. So topic 1 and 7 are closer to each other. Then topic 2 and 4, they got a lot of overlap, and they're close with topic 10. So or topic 5 and 6 are pretty much the same here. So you can identify cluster of topics. So when in Iran election we did it, so there were conservatives, opposition, so you could see their discourses, they're much more pronounced. So, and these are very simple. For a structural topic model, there's a function called 2LDAVs. It's, convert your object to an LDAVs, and then with one click you can turn it to a nice visualization like this, and it is interactive.
Something called multi-dimensional scaling.
Yeah.
So what is it trying to plot?
So it's trying to reduce these topics it's not a principal, it's a principal coordinate. So it tries to bring it to 2 dimensions to show the relationship between the features associated with the topics and their probabilities, whether they can be seen as clusters in a 2-dimensional space, if you want to see them in 2-dimensional space. It's just a
so what is the data you're using to do MDA?
These are the topics. You see the matrix of betas and gammas and those things. That's the thing that's being used in the back for creating this visualization. And the terms association. So it's going to be a lot of dimensions. So you have to just bring it to 2 dimensions to see whether it can be.
Is this in your code or is this something different?
No, this is different, but it's pretty simple to do that. You have to just convert that topic model to an LDAVs object and then run the LDAVs. Mark did many of these, so if you reach out to him, so just refer. So he's an expert. I remember that he has to go tweak a lot of JavaScript to be able to run it on a server somewhere. Okay, I think that concludes our workshop. Okay. Thank you. I hope you find it useful.